any reinforcement. Without any reinforcement, either you can go for a plain cement concrete or random rubble masonry, RR masonry. The second type, you can go up to for 20 feet height, you can fabricate it as a vertical wall, that is called as a stem with a base slab. Again, the base slab also will be normally 40% of its height. When you want to retain 20 feet, the base slab will be 8 feet. So that 40% ratio always you have to maintain. Later on I will be telling why you want to maintain that one. Then when the height is more and more, it's very difficult for us to go for the construction of the cantilever type retaining wall. We'll be introducing beams. When the beam is introducing on the tension phase, it is called as a counterfort type. When the beam is introduced on the compression phase, it is called as a buttress type. So this is what the popular retaining system. Then with this system, what is the modification that we can do with the textile reinforcement? Because we have to learn what forms of the textile reinforcements are available, how we can effectively utilize all these things. So for that, furthermore, you just try to understand. Quickly, let us go for the pictorial representations where we will be using. You see that this gravity retaining wall. This gravity retaining wall you can replace with textile reinforcement. That is possible nowadays. Similarly, again we have the reinforcement that we can provide on the inner. This is called as a cantilever retaining wall. This is called as a buttress type retaining wall that can be used for dams also. Buttress type dams you might have. For this only we are using, okay, for this only we are using geotextiles or geo reinforcements. What kind of modification you can do with these walls? Because you know that, don't think that this is a structural element. It is not a structural element. The outer portion of the wall is not a structural element. What it will offer, that you try to understand. Because this wall normally this, because what is the height normally we will provide for the under passage, you know, because there will be a crossing. For that only you have to go for the retaining structure. So that is normally between 6 to 8 meters. So when you are providing the underpass 6 to 8 meter, then you need to construct the retaining wall for a height of 6 to 8 meter, roughly 20 feet. So generally we prefer to go for the construction of this wall for a height of 20 feet. So the 20 feet wall, instead of conventionally going for 20 feet, we know it is cantilever wall is suitable. For 20 feet height, cantilever retaining wall is suitable. Right? Instead of going for cantilever type, we can go for this type of wall. That is what we are calling it as reinforced soil retaining wall. This reinforcement soil retaining wall, the concept is entirely different from the conventional design of the retaining wall. First, let us try to understand what conventionally we do. Then we will come back for this one. Then we can nailing, then we can go for the anchorage, sheet piles, all these are classifications. All these things that we can understand pictorially. So there is green retaining wall, crib walls and all these things. Now let us try to understand what are all the forces which will act. Either it is for a retaining wall or a reinforcing retaining wall. So these are all the forces. The lateral earth pressure is the major force. Major will be having the lateral earth pressure. Then we have the additional loads. That is, we are calling it as a surcharge loads. Surcharge load is nothing but, because you know that when you are constructing the retaining wall, even very small retaining walls we used to construct. Even for 3 feet, 4 feet also we will construct. When you go to a railway station, all the platforms are made of retaining walls for a height of 4 or 5 feet. So the use of the retaining wall, there you have lot of weight. Okay. Retaining wall not only has to resist the horizontal load, you have surcharges also. So that is one simple example. Likewise, you have other axial loads, then impact forces, then we have the earth pressure offered by the seismic forces. How to balance these forces? Because you know, when these forces are, the system of forces are acting on this wall, then we'll try to understand really how these forces can be effectively transferred to the system. The earth pressure, I think all you know, you might have learned basically with the soil mechanics. So the earth pressure you can calculate only for 5 soils, because you know the coefficient of the active earth pressure is 1 minus sin pi by 1 plus sin pi. There are two different concepts or two different theories are there. to calculate the earth pressure. One is Rankine's theory, another one is Coulomb's theory. Based on Rankine's theory, because most of the designs we will follow the Rankine's theory. The Coulomb's theory will have an advantage that, what is the advantage of the Coulomb's theory? The Coulomb's theory will take effect of friction in the vertical surface. When the effect of friction of, all you know that I think what is the coefficient of friction between base slab and soil? When concrete is provided in the horizontal surface, coefficient normally ranges from 0.4 to 0.6. So 50% of the friction which will be offered when the soil is in contact with the concrete, that is in the horizontal state. But in the vertical size or in the vertical side, the coefficient of friction only 15%, that is 1.5. It will be around 10 to 15% only. So this 10 to 20% additionally will be strengthened. That's what the Coulomb's effect. The Coulomb's effect or the Coulomb's theory will tell that there will be two components for the earth pressure. One is horizontal component, another one is vertical component. The vertical component is the friction in between soil and wall. When the friction between soil and vertical wall is not taken into account, it is called as Rankine's theory. When the friction between soil and wall is taken into account, it is called as Coulomb's. That's what the basic difference. But practically, normally, we will follow always the Rankine's theory. So based on Rankine's theory, active earth pressure formula is 1 minus sin phi by 1 plus sin phi. That is for the horizontal backfill, because you know this is the horizontal backfill. Then for the inclined backfill, the equation is different. It will be cos alpha into cos alpha minus root of cos square alpha minus cos square phi. That's what the formula that normally will follow. And we will not be always having the dry soil, because the soil always sometimes maybe 2 meters from the top or 3 or 4 feet from the top. In many places, the soil will be saturated. There will be a saturated soil mass. So we have to understand that how the saturated soil mass can be taken into account. Again, for that, the earth pressure theories are different, because you have to draw for different conditions. That is the dry leveled backfill. That's what you will be learning. That is the ideal condition. Then you will be having the moisture. Moisture means the water content. So based on water content, you can calculate how much, because you know that the pressure, it's very simple. If you are having a pie soil, I am telling about, pie soil will have angle of internal friction 30 degrees. So when the weight in the vertical direction is 100, the pressure in the horizontal direction will be 1/3, that's all. When your weight is 100 kilonewton, horizontal pressure will be 33 kilonewton. Only 1/3. But when the water is present, then the pressure increases. But the pressure maximum increases to 50%. So you have to calculate what is the horizontal pressure for dry condition and wet condition. In dry condition, the horizontal pressure normally will be 30% of the vertical part. In the dry maximum, I'm telling maximum wet condition. Maximum wet condition is 100% saturated. If the degree of saturation is 100%, for the 100% saturated soil, the percentage or the component of the force in the horizontal direction will be 50% of the vertical direction. That's all. So, which means that all the cantilever retaining wall, whatever may be the retaining wall, whatever the retaining wall that you are going to design, the vertical wall always will be subjected to 30 to 50% in the horizontal direction. So that is what you have to understand. Whatever may be the variation, you may have all these variations. You may have moisture, you may have submerged and leveled backfill with surcharge, whatever the condition you have, only 50% that will be exerted. It is similar to your earthquake. Earthquake, I think you might have learned what is earthquake. The ground acceleration. The ground in acceleration in the vertical direction is 9.81 meter per second square. If the acceleration in the horizontal direction is half, then we will be feeling all the damages. When the ground acceleration is 0.1% or 10% or 20%, 0.1 or 2, we cannot feel, and always it will happen. Even now what we are sitting in this part of the earth, always movement will be there below the earth. So if you see that, same thing will happen here. 50% of the earthquake destroys. Similarly, 50% of the backfill pressure always destroys your wall. So you have to critically review and you have to critically design that. How to take into account of the 50% of the vertical force in the horizontal direction. That's what you have to do it over here. So that normally ranges from 30 to 50. Minimum 30, maximum 50. That's what you have to calculate. Then, while after calculating all these things, there are a few other things that you have to understand. These are all the formulas I told you. That's what inclined backfill, the cos theta formula. The stability, I told you, there are two types of stability are there. First part, I think already I told you that. In the sliding case, the sliding case, in the sliding case, the friction offered in the horizontal direction is 50%. So what you have to do that? The first thing, the wall should not slide in the horizontal direction. Basically, if the wall is not sliding in the horizontal direction, for that, purposefully that you have to introduce the base width. When the base width is approximately 40% of your height of retention, it will not slide, first thing. The second important thing that when you are introducing the base width, because the friction is associated with how long or how much base width that you have. As you increase the base width, obviously, friction also increases. When the friction is increases, you cannot keep on increasing the base width always. That is also not possible. When there is no possibility of increasing the base width, first you have to realize that. First very important thing that you have to realize that you have to provide some keys at the base. That key is what you are providing on this base, that is called as shear key. Because the horizontal force here has to be called as shear force. Because the wall is in the vertical direction. This wall is in the vertical direction. The force is acting in the horizontal direction. It is like tilting your beam, isn't it? Beam is in the horizontal direction, load in the vertical direction. Here the structure is in the vertical direction, load in the horizontal direction. Thereby, you have to introduce the shear keys at the bottom. To take care of more earth pressure, the shear keys needed to be introduced on the bottom. So, you can design. The design always has to be started after satisfying the stability requirement. Normally, what you will be doing a design in RCC subject, you will be designing for strength. Any beam, you see, take example of one beam, any beam, this, if you want to design this beam, first you will be taking what all the forces are there. Then you will be calculating, because beams always subjected to bending, you have to calculate bending moment and shear force. Then you will be designing. But here it is not so. Retaining structures always has to be designed first and foremost. First it has to satisfy the stability requirements. The stability requirement of the stem, stability requirement of base slab. So to satisfy this one, first you have to verify whether the key is necessary or not. When key is necessary, first you have to calculate what is the size of key is necessary. What is the size of the key is necessary. After calculation of the size of key only, you can come up with final solution. Then finally you can design. In beams, what normally you do that? Here, suppose if this beam is there, in the middle of this beam, you will be verifying what is maximum deformation or deflection. Those kind of the deflection checks are not necessary over here, because it is designed for stability. It is not designed for strength. When structure is designed for stability, the deformation is not important. Deformation is not a defining parameter. Only stability is a defining parameter. Why? Because the excessive deformation occurs when the material goes into the inelastic region, beyond elastic region. When you are making an attempt and solving the problem for stability, the material will never go to the maximum force. For stability problems, you might have learnt in columns, isn't it? Columns also you learnt the Rankin's theory, the critical buckling load. When you calculate the critical buckling load always will be less than the crushing load. If material crushes, load will be 2000 kilonewton. If the material buckles, the load will be 1000 kilonewton. So the material will never reach the full stress. Similarly, the retaining walls will never reach the full stress. because the retaining walls are designed for stability. When the walls are needed to design for stability, strength is not a defining parameter. So strength is a second parameter. If you want, you can find the strength, but because of the strength, it will not fail. The retaining wall will fail only by stability. So for stability, first defining parameter is sliding. The second defining parameter is overturning. To take care of overturning, there are few things always you need to understand. The first thing, the base width required is 40% of its height. First thing. The second thing, you are calculating the maximum pressure and minimum pressure. Since you are going to rest the retaining wall on soil, the retaining wall, this entire retaining wall will be resting on soil. Underneath soil will be there. Since the material of construction, the concrete material will be concrete material will be, or the concrete material is supported on earth. Earth will not accept any tension at all. Whatever the earth you have, always you are defining, isn't it? You will be finding out first basic soil characteristic. What is degree of saturation, void ratio, water content. Similarly, you will be next, you will be calculating what is earth pressure, saturated or unsaturated. Then what you'll be doing that, you'll be finding what is safe bearing capacity. Then based on safe bearing capacity, you'll be drawing the pressure bulbs, isobars and all these things. Isn't it? There will be several concepts, Busnick's formula and several formula are there. But never you might have learned what is tension carrying capacity of soil. Because soil will never take care of any tension. Soil will never take any tension. Therefore, always what you have to do that, the resting of this wall, whatever the base slab that you are resting on soil, that soil should never be exposed to tension. The soil, base soil will be always under compression. And for that, first you try to understand, imagine that we have 10 feet height retaining wall. If you are providing 10 feet base width, if you are providing 10 feet base width, one by one, whatever the height of the retention is 10 feet, then base slab is also 10 feet. In that case, mostly compression will be there on two sides. The compression will be there on this side, that is on the toe end and on the heel end. Then, when you are coming for 50%, 10 feet height and 4 feet base or 5 feet base width, this will be subjected to more pressure in compression, this will be subjected to less pressure in compression. When you are providing 1:3, that is 10 feet height and 3 feet base, for that, this will be subjected to maximum compression and this will be subjected to maximum tension. That's what you have to follow the middle third rule. Whatever the number of forces you have, you may have horizontal earth pressure, weight of concrete, weight of surcharge. Just add all these weights. You know principle of resolution in the engineering mechanics. Many number of forces can be converted into a single force. Based on the concept of the principle of resolution, you have to find what is the total resultant, net resultant. That net resultant always has to pass within the middle third of your soil surface, not on the concrete surface. Isn't it? You are going to rest your concrete to a wall. Total forces that has to pass through the middle third. That's what we are calling it as middle third rule. For effectively utilizing the middle third rule only, we are going for 40% height. Then if you are interested, suppose if you want to reduce the size, you can go for 35% or 30%. Whichever the percentage of the total height which is involving with the, or which is satisfying the middle third rule, that is your base. You have to do more number of combinations. 30% of base width, 35% of base width, 40% of the whichever is offering both phases, both toe end and heel end, that is under compression always. When this phase is undergoing tension, this toppling will be there. That's what we are calling it as overturning. So to avoid overturning, that you have to fix it. That's first thing. Second thing, you are having the maximum pressure on this end. The maximum pressure which will be offered from the toe end. The maximum pressure will be offered from the toe end. So here, condition is the pressure at this end should not be more than, say, bearing capacity of the soil. Even though you are resisting the tension, at the same time, you have to verify one more thing also. At this point, there should not be any more pressure than your bearing ability of the soil. You can calculate self bearing capacity of the soil. So at this end, the pressure should not be more than that. So this is what the concept which will be utilized in the design of cantilever type of retaining wall. So here what you have to understand, to resist this one, to resist this backfill, or to avoid the sliding of this backfill, and you know this angle what we are maintaining as 90 degree. So to make 90 degree, and you can have one more slope over here, that's what your angle of internal friction. So based on the angle of internal friction of soil, how much depth has to be retained, for that only we are designing this wall. So in this wall, what are the modifications that we can do so that you can go and do a practice with reference to the design of the textile reinforcement. For that, what we need to do that here, we have to draw a line. We have to draw a line from this point based on the angle of internal friction, where you are going to rest your entire thing, or where you are going to rest your entire retaining wall. From this point, you have to draw a line or a slope line based on your angle of internal friction. And if you are drawing a line from this point, this part of the soil will not have a problem. Only this part of the soil you have to retain. So to retain this part of the soil, you have to go for soil engineering by means of geotextiles. That's what the need for us. So for that, what normally we have to do that. Suppose if you are having this as 20 feet, you can divide this into equal 2 feet. So 10 parts. For the first part, only small retention. So one layer is sufficient. For the second part, somewhat heavier, 2 layers, 3 layers, and you can go up to 10 or 12 layers. So this is what the concept that we will be doing it. That we are breaking the chain of sliding. When the soil is, or when the soil is there in through a particular slope or a heap, we have to break it in the horizontal direction. So horizontally, instead of this wall also breaks, isn't it? The integrity of the soil on the side is broken by this wall. Similarly, instead of this wall, horizontally you just have the layer. So that is nothing but a material or a fabric. There are two types of fabrics you can use, woven and non-woven. I think somebody might have explained you. Later on we'll be trying to understand. So after understanding this cantilever retaining wall, next you have to understand through which you have to start, where you have to start. Only because you know that there is no material in olden days which is available other than the concrete material to have the failure of this soil. What will happen? The soil will slide. So for this portion of the soil not to slide only, we are introducing the geotextiles or membranes. Several things are there. All those things that you can introduce. Next, let us quickly understand the other things also. So these are all the things already I explained you. These are equations that you have to use. Because for the depth you know, always will be limited to 3 to 6 feet maximum. That's all. After even you calculate that, you will be arriving with 3 feet or 4 feet. So this is a design. It is not necessary for us. A simple example I have been given here. So you can calculate, and you can calculate total force and total pressure, and finally you can see that. Always I told you that this part always should be less than your say bearing capacity of the soil, and this part it should not more than your compression. No tension that should be there. Always it will be under compression. That's what the critical. Then there are two checks are there. So usually one mistake normally we do that. Actually, the factor of safety against sliding and overturning always has to be 1.55. It's not 1.5. Many people used to mistake this one because you know that this is available in IRC for IES 456. So if you refer IS 456, these values will be given. Stability against sliding and overturn. Value is 1.55. It is not 1.5. There is lot of difference between 1.5 and 1.55, especially in the design of retaining walls. So whatever thing is given in the code that we have to follow. That was, you can see that the maximum pressure always has to be less than SPC, and there is no tension on the minimum pressure. That should be more than 0. If both values are positive, both are under compression. That's what the concept here. And you can see that how to design, because it is cantilever. So for heel slab, cantilever reinforcement will be provided on top. In toe slab also you can do the same thing. You can provide the steel on the cantilever piece. This is the cantilever piece for toe slab. Then this is what the pattern of reinforcement. Not to have these kind of the reinforcement only, we are providing the horizontal reinforcement. Instead of providing the vertical reinforcement, we are going to provide the horizontal. That's it. So these are all the important points. And just I'll be telling you what is the usefulness of the counterfort. Then we'll go for soil engineering. So here the counterforts, these counterforts, this is a counterfort. This counterfort will be designed as a beam. Counterfort is always a continuous beam. Counterfort is always a continuous beam. But here, the beam is not rectangular in cross section. You should not get confused that usually all the beams will be rectangular in shape. This beam is triangularly varying. This beam is triangularly varying. It is a cantilever beam. So this cantilever beam is triangularly varying. This cantilever beam is a triangularly varying. And this face will be subjected to tension. I told you already, counterfort retaining wall are carrying always tension. So this face will take care of tension. This counterfort will be taking care of tension. Stem will be a continuous slab. Usually in cantilever retaining wall, stem is a cantilever. Whereas here, stem is a continuous wall. Stem is a continuous wall. Counterfort is a beam which is triangularly varying. The sloping side is a tension phase. When the sloping side is a tension phase, vertical side will be a compression phase. Vertical side will be a compression phase. Then the sloping side will be a tension phase. So that's what you have to understand. You can see that. So this is like a beam. This is like a beam triangularly varying. This is like a beam triangularly varying. So continuous beams are introduced. Continuous beams are introduced. For that you have to design. Stem will be designed as a, you can see that it is a continuous, and positive bending moment and negative bending moment has to be calculated. Then the heel slab also will be designed. Now you can see that because of this tension phase, this is the red in color is nothing but reinforcement. The reinforcement, because the reinforcement will be placed on the tension phase. The reinforcement will be placed on the tension phase, and this is compression reinforcement or the minimum reinforcement. So this is what the difference that you have to understand, and this is what the three-dimensional view of a counterfort retaining wall. That you can see that this is base slab, this is stem, because you know that cantilever retaining wall will have slope. Because of continuous sections what is required is less. For example, for cantilever retaining wall, if the thickness is required 450 millimeter, for counterfort it is required only 150 or 100 mm. Therefore, rectangular walls will be preferred in the vertical direction. Similarly, base slab also will be a rectangular one. These counterforts will carry the entire load. It is difficult for us to fabricate the counterforts in the field. That is why we are not preferring the counterfort. If you see the economical condition, comparing all these things, compare the gravity retaining wall, counterfort, cantilever, buttress and all these things, counterfort retaining wall is highly economical than all other things. The thickness is very less. You see that 450 mm and 100 or 120 mm is sufficient. That is what the advantage of this one. So the designs not necessary. Just try to understand. Now let us go and try to understand what is soil reinforcement. These are all the analytical calculations only. How to calculate the horizontal and vertical. First, I think somebody might have given introduction about this. You have synthetics. Okay. Then you have the textiles, membranes or composites. Especially we try to use the composites rather than other things. Next. Then the functions also known to you. It will be adding as a separator or filter. It can control the erosion by means of river water or canal and all these things. Next. Let's try to understand as we discussed already. Not only for the retention purpose, there are several other functions are there for the geotextiles. So the geotextiles, you can see that it prevents the sliding, then erosion, whatever the geotextile, it can use it as a filter, then it can use as a cushion. All these applications are there because you know that there are several structural and non-structural applications are there here. So first you have to segregate that which application you want to do, whether you want to go for a structural thing or a non-structural thing, because there are non-structural aspects or there are non-structural things also will be there, but mainly we'll be concentrating on structural aspects. You see that the geotextiles can be used as a reinforcement. You see that there is a reinforcement, you can use it some layers and you can use it. Especially these reinforcements, you try to understand what is the reinforcement normally we'll be using in the geotextiles. In geotextiles, the reinforcement will not be used like bars like your mild steel reinforcement. In mild steel reinforcement, you will be using bars. And not only geotextiles, any textile reinforcement always will be having a base layer. A base layer. That base layer, it will be either woven or non-woven. There are two types of bases are there, woven or non-woven. Then, whether you are using woven or non-woven, it will be reinforced by means of binders. It will be added or it will be sandwiched by means of binder. The excellent binder, you know, the excellent binder is epoxy. Other than epoxy, you have ISO resins. You have GP resins, general purpose resin. What you have, this handle is made of general purpose resin. You see that in fans, the sides, they are made of, that is also woven only. A woven layer which will be added with 2 or 3 sandwiches. Intermediately, always you will be having resins. Aircrafts, ships, boats and all, people will be going for epoxy resins. They are going for e-glass fibers and epoxy resins. That kind of amount or the estimate that we cannot do with the geotextiles. So for geotextiles, mostly we will be going for natural products, natural resins and natural ovens. So that is the basic difference. Other than that, functions are same. And you know that steel is a ductile material. I think all you know, steel is a ductile material. And moreover, steel is a homogeneous and isotropic material. The basic difference between this material with the other that you have to understand. Steel will be a homogeneous and isotropic material, whereas woven and whatever the reinforcement that you have, it will be an orthotropic material. The basic difference between the isotropic material and orthotropic material is that isotropic material, the properties and behavior in all the three dimensions, if it is same, it is called as isotropic. If properties and behaviors in two mutually perpendicular direction are same and the third direction is different, planes. Plane means xy plane, yz plane and zx plane. If xy and yz plane, if the property and behavior are same and that is different from zx plane, it is called as orthotropic material. Most of the fibers are orthotropic. So it is not like steel you can design. Conventionally you are designing steel in the vertical direction, steel in the horizontal direction and all. But the design, the orientation of the fabric is important. The fabric you are wearing also as cloth. This cloth also will have resin. Not a simple resin. The resin which will not get any affection or any indentation in your body. Such a way that people will be adding resins here also. So the textiles and resins are in several forms. Many forms are there. Which form of the textile which is useful, that you can utilize here. So that is what we are going to discuss over here. So there are two types of geotextiles which normally will be doing. One is woven. Woven is nothing but it will be available like bundles. Bundle of length of 100 meter, 200 meter and all. So first layer, then apply the resin. Second layer, third layer. So how many layers or what is the thickness you require, you can use. The non-woven mainly, it is also continuous only, but it will have a lot of pores. So where you want to go for a porous-like structure, isn't it? And then water seepage and all will be there. So in those places you can go for non-woven. When you want to resist and when you want to go for a structural strengthening, you can go for woven. And there are a lot of applications are there. You can see all these applications: soil erosion, the bank protection, then we have stability, then consolidation, then vegetation support. In all these places that we can use the geotextiles. The two types of the natural geotextiles, that what we can discuss now. The one type is coir, another one is jute. So the coir geotextiles, you can see that it is natural. That is organic material. Natural material, it can be used or it can be molded, then no chemical treatment is required. So that is what the advantage is here. You can see that it is excellent and it is more durable against water. Then normally it will live for 1 to 5 or 6 years. Because you know that you cannot compare the natural textile material with the artificially made material. Artificially made materials will live for 50 or 100 years. But the cost is very high. But natural material, every 2 or 3 years you can replace. That's what the advantage. And you can have a lot of application. That is, you can go for the drainage blanket, then embankment, side slope strengthening, then control of erosion, normally by water or wind. For all these things that you can utilize. So this is what is important, that how it can be installed. So the installation procedure. First you have to make a ground, then you have to spread it. Then whatever thing that you can go for nailing or stapling, then across that you can do. This is what a pictorial representation of manufacturing or providing the geotextiles. Then you can see that there are a lot of applications are there. You can strengthen the side slope or you can strengthen the ground also. So to improve the ground and have erosion effects or remove the erosion effects, you can do that. So this is one simple example of the banks and the slope protection by a coir. Then the techniques, that is what I told you already. Then you can go for the stapling or netting at an interval of 3 to 4 feet interval. Then grass will grow and control it. So when the vegetations are there, the erosion can be controlled. Then the dense natural fibers that produces lot of good effects, that is erosion can be affected and you can go for the fiber matrix also. Then the dense natural fibers dissipate the wave energy, then protect the banks. And it also helps the grow of plants. Then the second one is jute. Jute is normally we will be using jute for many purposes. Whatever may be the purpose of jute that we can use, it is also a natural. It is a biodegradable material. This is also can be useful for 1 to 6 years. Its life is 1 to 6 years only. Then the components, what are the chemical components? It has mostly nitrogen. Then it can be applied for erosion, agriculture use, and reflection of cracks, and all these applications that we have. Then any woven material you can compare with these basic parameters. The first parameter is its weight. What is the weight of material in a square meter? So GSM means grams per square meter. So what is the weight? Usually conventional artificial fabrics will have 600 or 500. Now you can compare 500 and 600 grams with this because it possesses higher weight than the conventional material. Most of the natural fibers always will be having weight more than the artificial materials. That is E-glass and all will be less, 600, 400, 300 something. Here it is always more. Then you can, width and all other things you can understand, and you can see that the durability also very less, 1 year or 4 years, that's all. Then for non-woven also you have 2 types, and its durability is again 1 year. Then there are few applications people are doing nowadays, and based on the environment also we can see there is no environmental threat. Then when you are using the polypropylene, it will be harmful material. Compared to that, it is good. So it is made of natural material, and it has have 1 to 5 years of period. Then it can be useful for all these applications. That is wind barrier, then the coastal application, beaches, and all these places that you can apply. And the coir fiber blacks also that you can manufacture. So you can see that you can go for the short time or 4 to 5 years of installation, anything that you can do that. So one of the simple case study that has been done in NH17, those pictures now you can see that. So whatever the sinking part is there, that has been renewed. Then the landscape protected by the coir, that is another case study, and we can use it logs or roads, and it can be used for some more purposes also. So the natural geotextiles, it can be used for the erosion control. The production cost is less, as I told you already. Then they are very hard. It can be used for temporary reinforcement also. Natural geotextiles, they are eco-friendly. Then the coils also can be used. Then compared to the polypropylene fiber, they are much superior. So this is what I want to tell you. If you have any doubt, we can discuss now. What we discussed so far, if you have any doubt, you can discuss. Somebody want to ask some questions? You can ask now. Any questions you can ask.
You have discussed about the width of the base and the height of the stem set. So for the stem height, we will take 40% for the base. But what is the thickness of the stem and that relation like this?
Actually, the thickness is based on the forces. So you cannot have some basic formula for the thickness. When you are having 10 feet height, your force will be entirely different. for saturated and unsaturated condition. So therefore, the thickness always you can find only with reference to strength, not with reference to stability. What we discussed based on stability, not based on strength. Because I told you strength is a secondary parameter. So normally after completing that you can design. So whatever the design thickness is required you can provide, but there is no specific formula for that. Any other question?
Is this TRC will reduce the volume of concrete, sir?
When we are using the TRC, we can compare. TRC is a structure which will be used for 5 to 10 years, that's all. Whereas the concrete will be used for 40 to 50 years. So accordingly the cost will be reduced. When we are going for TRC, cost will be roughly 20 to 30% of the return. The cost reduction will be always there. But for the structural application, you have to go for the epoxy resin and wovens. That woven roving is made of e-glass fibers. Again, e-glass fibers, we have chopped strand mat. Several varieties are there. So whatever the CSM mat or any other mat if you want to use, you have to use with the epoxy resin. Then it will be slightly costlier. Artificial fibers are costlier than the natural fibers. Any other questions from the back side?
Kayaks and jutes are not an abundant material. So then why should we recommend that?
Both are sustainable material, natural material, organic material, you can use it. About the material utilization, it is not a problem. Only thing, the strength aspect that can be used for the non-structural applications. And over it all, very short lifespan, hardly 1 to 5 years. But fiber and all, it will live for 50 to 60 years, artificial fibers. Woven roving or CSM, all these mats will have more than 60 or 70 years of lifespan.
In retaining walls, sir, if we are using the TRC in horizontal direction, that bar bending actually, the traditional, how many percentage of bars will get reduced, sir? Percentage, just.
We are introducing the textile reinforcement in horizontal layer, thereby absolutely not necessary of reinforcement. Minimum reinforcement is necessary. Normally in cantilever type retaining wall, we will be providing 2% of reinforcement. Minimum reinforcement in walls is 0.15. So we can save almost 80% of the reinforcement. You can understand, for vertical walls, minimum reinforcement is necessary. When you are going for cantilever, you will be using 2%. So 2 minus 0.15 by 2. So almost 90% reinforcement you can reduce. That's what this advantage. Only thing, the soil slides. That sliding soil, if the length is there on the one side, it is not at all a problem. If the retention length is not available, you have to go for this. That's what the basic concept. Even we can stop the retaining wall with its angle of internal friction, and people are not doing it. Where the angle of internal friction, where the natural slope is available, up at that point they can stop it. Beyond that also it is not necessary. So that also we have to do when we are designing it. Especially for the abutments and banks it is necessary, but for road surface it is not necessary. After that they can provide some vegetation also, then it will be good. Especially if you see, I think in our part, if you go from Metupalayam to Kunnur, very weak soil, you will be always finding lot of slides. And they are going nowadays for gabion walls. Same only. That reinforcement provided in vertical and horizontal direction. Layer by layer of stones. I think all you heard about gabion walls. The rocks will be the rods will be on the outer surface. Then they will be backing with the weight. For weight, providing weight, they will be providing rocks. So that is also a form of reinforcement. Gabion walls, that is what more popular in very, very weak soil. Very, very weak soil, you can go for Gabion walls. Gabion walls also, steel reinforcement, steel textile reinforcement, we can call it as Gabion wall.
பிஆர்சி ரெயின்ஃபோர்ஸ்மெண்ட் யூஸ் பண்ணும்போது வந்து ரீட்டைனிங் வாலோட டிசைன் இப்படி சேஞ்ச் ஆகணும் சார், கன்வென்ஷனலுக்கும் இருக்கும்.
Because we are breaking the chain. So for the first chain, how much is the pressure? And what is the length in which the pressure is offered? Here, the retaining wall you will be designing for 1 meter in this direction. Here you have to consider this horizontal. So whatever the total weight in the horizontal direction by its width. So width is constant. Every 1 feet or every 2 feet you are going to break the chain. But horizontally the length is different. Top will have 5 meter, then 4.54. So accordingly you can design. How much pressure is there? Then based on whatever the material required for top, uniformly you can provide. Otherwise, if you want to change the material, you can have slope. When you are having the slope also, you can break the chain. But only thing, horizontally, what is the length is there, that you have to consider. But retaining wall normally designed for stretch, 200 meter, 300 meter, 1 meter will be designed. Here we can't do it. We have to do it in the horizontal direction. That's what the process. This direction has been converted into a transverse direction. Any more questions from the back side? Nobody has. Okay, thank you. Thank you all.
Thank you for the essential information, sir. We are sure your expertise will guide us to a great extent.
All of us do not have equal talents, yet all of us have an equal opportunity to develop our talents. One said Ratan Tata. On this special occasion, I invite Dr. K. Srinivasan sir, Assistant Professor SS, to honor our chief guest with a memento.
As we are approaching towards the decline of the session, I thank everyone for being a part of this session. We request all the participants to stay back for the feedback session before going for the refreshment. We deem it a great privilege to welcome all the intellectuals onto the dais. Intelligence plus character, that is the goal of true education, once said Martin Luther King.
A very pleasant morning to our Honorable Chief Guest, Engineer D. Charumadi Ma'am, Respected Dr. A. Sendil Kumar Sir, Dean, Academic and Autonomous, Dr. K. Murali Sir, Professor and Head, Department of Civil Engineering, all the faculties and my dear participants.
We cordially welcome Dr. K. Murali, Professor and Head, to deliver the welcome address. Thank you for this precious words, sir.
கல்வி கலையை காட்டாராக ஓடவிடும் எங்கள் ஏ கலைவனின் பாதையில் ஓர் சிறுதுளி. We feel gratitude to invite Dr. K. Sendil Kumar Sir, Dean, Academic and Autonomous, to convey the presidential address.
title, I just look this in electronics perspective. Now all electronics become smart. Smart TV, smart washing machine, everything is smart. So this also going to be smart because of the textile reinforcement. Actually, there are some smart concretes available. I came to know that 7-8 years back itself this has been introduced by adding carbon fibers in the concrete. The concrete made as conductive material, and it produces. It changes stress and strain will change the resistivity of the material. By measuring the resistance of the material, we can know that is there appropriate stress or strain is on the concrete. So actually, this is the next level. I understand. So we are instead of iron rods, they are using a textile material. I think so. Please excuse me if I am wrong. Right? So instead of the textile fibers, we can mix carbon materials as well. Carbon fiber as well in the along with the textile, and this also made conductive. And also I understand that the size of the concrete requirement is less compared to metal reinforced concrete. So definitely we can make it smart. So the civil people can join with electronics people. This is a personal interest. You can make a IoT based concrete, and you can measure, continuously monitor the stress and strain of the building and big structures like bridges. Okay. So with this, I appreciate all the coordinators and participants who are eagerly participating in this activity. Wish you all the best. Thank you.
Thank you for your valuable speech, sir.
Now we call upon Mr. S. Dinesh Kumar sir, Assistant Professor, to deliver the introduction of our chief guest.
Good afternoon to one and all. It's giving me an immense pleasure in introducing our alumni, the IDSG Charmali of 2009 to 13 batch. She has completed her BE in Civil Engineering at Dr. Mahalingam College of Engineering and Technology and ME Structural Engineering at USC College of Technology and City in the year 2009 to 15. Currently, she is working as an assistant engineer, highway department, Tamil Nadu, in special project Coimbatore. At present, she is involved in Avinashi elevator road and the bridge project of about 10.10 kilometer at Coimbatore. Once again, I welcome our chief guest, Charmati, on the behalf of Dr. Mahalingam College of Engineering and Technology and Civil Department.
Thank you, sir. Things may come to those who wait, but only the things left by those who hustle. A famous quote given by Abraham Lincoln.
We are delighted to invite our chief guest, Engineer D. Charumadi ma'am from Highways Department, Coimbatore, to deliver the chief guest address.
Humbled to be here in this position. So first the major reason, இப்போ நான் இங்க இருக்கிறதுக்கு major reason வந்து teachers தான். இங்க இருக்க teachers. So faculty members வந்து they play an important role in our life. Actually இங்க இருக்கும்போது we will not know how much importance and how much impact they create. Once if you go out of your college, உங்க teachers சொல்லி கொடுத்த அவங்களோட ஆட்டிடியூட்ல இருந்து தான் you will grow. அவங்களோட ஆட்டிடியூட் தான் நீங்க. So after you complete your 12th நீங்க இங்க வரீங்க, நீங்க ஒரு clay mark தான். So your BE இருக்கிற அந்த graduation the teachers mold you without your knowledge. நீங்க வந்து தெரியாமலே you will get molded by them. So அதுல வந்து நம்ம colleges இங்க இருந்து போற எல்லாருமே வந்து they are shining. Any field, be it any field, construction field or government or any entrepreneurship, எந்த field ஆ இருந்தாலும் indirectly how our teachers have molded us plays a part. அது எல்லாமே realize பண்ணணும். After going out we are realizing. So first யூ ரெஸ்பெக்ட் யுவர் டீச்சர். மாதா பிதா குரு தெய்வம்ங்கிறது வந்து உண்மைதாங்கிறது கோயிங் அவுட் ஐடியலைஸ்டு இங்க இருக்கும்போது தெரியல. ஸோ கமிங் டு த பாயிண்ட், உங்களுக்கு எல்லாத்துக்குமே வந்து இங்க வர ஜிபிஎஸ்ல இருந்து டீச்சர்ஸ்ல இருந்து பேரண்ட்ஸ்ல இருந்து எவ்ரிவன் வில் ஹேவ் கிவன் யூ அ டு டூ லிஸ்ட். என்னென்ன பண்ணா நீங்க வந்து சக்சஸ் ஆகலாம், வாட் ஆர் திங்ஸ் டு டூ டு சக்சீட் இன் யுவர் லைஃப். லைக் இப்போ நல்லா படிக்கணும், நல்லா மார்க்ஸ் ஸ்கோர் பண்ணணும், அப்புறம் நல்ல கேம்பஸ்ல நல்லா அட்டென்ட் பண்ணணும், நல்ல இங்கிலீஷ் நாலேஜ் இருக்கணும். இது மட்டும் இருந்தா போதும், ஃபர்ஸ்ட் இதுல கான்சென்ட்ரேட் பண்ணுங்க, ஒன்லி தென் யூ கேன் சக்சீடுங்கிறது வந்து எல்லாருக்கும் சொல்றது தான். ஸோ ஐ எம் நாட் கோயிங் டு டினை தட். பட் education, studies is important, but studies is not only important. Other than that, there are many skills which you can learn in this college. Okay, வெளிய போனதுக்கு அப்புறம் கம்பெனியோ இல்ல எந்த ஒரு ஆபீஸோ வெளிய உலகம் வந்து it is not expecting only studies from you. Basic வந்து you have to learn, that is very basic. But apart from that, skill development is very much important. ஒருத்தர்கிட்ட எப்படி கம்யூனிகேட் பண்றீங்க, ஒருத்தர்கிட்ட எப்படி you're using your presence of mind. ஒரு இடத்துல எங்க போய் விட்டாலும் you should survive. அப்படி இருக்கணும். if you are given a task you must complete. ஒரு நியூ திங்கை எவ்வளவு தூரம் சீக்கிரம் கிராஸ்ப் பண்றீங்க, இந்த எபிலிட்டிலாம் தான் வந்து சொசைட்டி அண்ட் கம்பெனிஸ் ஆர் எக்ஸ்பெக்டிங் ஃப்ரம் யூ. இது வந்து வெறும் ஸ்டடீஸ்ல தவிர ஸ்டடீஸ்ல மட்டும் வராது. யூ ஹாவ் டு டெவலப். இங்க இருக்க எல்லாருமே நம்மளுக்கு ஹெல்ப் தான் பண்ணுவாங்க, பட் யூ ஹாவ் டு டெவலப் யுவர் ஓன் இன்ட்ரெஸ்ட். வெளியே போங்க, நிறைய கெட் எக்ஸ்போஸ். தட்ஸ் வாட் ஐ சே. இப்போ ஒரு இம்ப்ளான் ட்ரைனிங் போறீங்களா, இன்டர்ன்ஷிப் போறீங்களா, ஜஸ்ட் முடிச்சோமா சர்டிஃபிகேட் வாங்கணுமான்னு இருக்க வேண்டாம். அங்க போனீங்கன்னா ஆஃபீஸ்ல, இப்போ ஒரு ஆஃபீஸ்க்கு போறீங்கன்னா அங்க இருக்கிற பீப்புளோட அப்சர்வ் பண்ணுங்க. அங்க எல்லாரும் என்னென்ன பொசிஷன்ல இருக்காங்க, எப்படி இருக்காங்கன்றத பாத்தீங்கன்னா உங்களுக்கு ஃபர்ஸ்ட் யூ வில் கெட் அ விஷ். ஆசை வந்துச்சு நம்ம இப்படி இருக்கணும் அப்படின்னு ஒரு ஆசை வந்தாதான் அதை எக்ஸிக்யூட் பண்ண ட்ரை பண்ணுவோம். ஸோ வாட் ஐ வில் சஜஸ்ட் இஸ் ப்ளீஸ் கோ கெட் எக்ஸ்போஸ்ட், கோ அவுட், கெட் குட் நெட்வொர்க். நிறைய பேர்கிட்ட பேசுங்க, நிறைய பொசிஷன்ல இருக்கவங்க கிட்ட பேசுங்க. யூ ஆர் இன் அ குட், ஃபர்ஸ்ட் இந்த பொசிஷன்ல இல்லாம நிறைய பேர் இருக்காங்க. யூ ஆர் இன் அ குட் பிளாட்ஃபார்ம். நீங்க யூ ஆர் சோ லக்கி டு கெட் இன் ஹியர். அது இப்போ உங்களுக்கு புரியாது, ஒன்ஸ் யூ கோ அவுட் யூ வில் கெட் டு நோ. ஸோ இங்க வந்து இருக்கிறதே ஒரு பெரிய விஷயம் தான். ஃபர்ஸ்ட் ஸ்டெப், மேக் யூஸ் ஆஃப் இட். இந்த டீனேஜ்ல யூ வில் எந்த அளவுக்கு வந்து கோயிங் அவுட் அண்ட் கோயிங் வித் யுவர் ஃப்ரெண்ட்ஸ் இஸ் இம்பார்ட்டன்ட்டோ, இந்த ஏஜை விட்டா யூ கான் கோ அவுட். யூ கான், நீங்க எங்க வேணா போங்க, என்ஜாய் பண்ணுங்க. பட் ஈக்குவலி இம்பார்ட்டன்ட், இந்த ஏஜ்ல தான் யூ கேன் லேர்ன். எந்த ஸ்கில்ஸ்னாலும் சீக்கிரம் இப்போதான் உங்களுக்கு வந்து ரெஜிஸ்டர் ஆகும். ஸோ இஃப் யூ லீவ் திஸ் ஏஜ் யூ ஆர் லைக் பட்டர்ஃப்ளைஸ். இந்த ஏஜ்ல நீங்க எடுத்துக்கிற எல்லாமே டக்கு டக்குன்னு கிராஸ்ப் ஆகிடும். ஸோ யூ கிராஸ்ப் திங்ஸ். இங்க இருக்க என்விரான்மெண்ட்டை யூஸ் பண்ணிக்கோங்க. ஸ்டூடெண்ட் லைஃப்ல இருந்து நீங்க லேர்ன் பண்ணிக்கிறது வெளியே போனா கிடைக்காது. ஒன்ஸ் யூ கோ அவுட் ஆஃப் திஸ் காலேஜ் யூ வில் ரியலைஸ் ஹவ் டஃப் லைஃப் இஸ். ஸோ இங்க இருக்கும்போதே யூ மேக் யூஸ் ஆஃப் ஆல் த ஆப்பர்ச்சுனிட்டிஸ். நீங்களே திங்க் பண்ணுங்க, உங்களுக்கு டீச்சர்ஸ் கைட் தான் பண்ணுவாங்க. நீங்க அவுட் ஆஃப் யுவர் ஓன் இன்ட்ரெஸ்ட் நீங்க நிறைய இடத்துக்கு போனீங்கன்னா யூ வில் கெட் டு நோ எப்படி லைஃப் இருக்க போகுதுங்கிறது. அது தெரிஞ்சாதான் யூ வில் பிளான். உங்களுக்கு உங்க லைஃப்ல பிளான் பண்ணிக்க முடியும். நான் படிச்சு ஒரே லைன்ல இப்போ கவர்மெண்ட் லைன்ல தான் போகணும், கன்ஸ்ட்ரக்ஷன் ஃபீல்ட்ல தான் போகணும் அப்படின்னு சொல்லலை. யூ மே ஹேவ் டேலண்ட்ஸ் இன் டிஃப்ரெண்ட் வேஸ். ஒவ்வொருத்தருக்கும் ஒரு டேலண்ட் இருக்கும். பட் எந்த டேலண்டாக இருந்தாலும் அதில் யூ ஹாவ் டு பி கிளியர், வெரி கிளியர். தெளிவு ரொம்ப முக்கியம். எந்த ஃபீல்டுக்கு போனாலும் தெளிவு ரொம்ப முக்கியம். நான் இங்கிருந்து காலேஜ் முடிச்சு இந்த ஜாப் முடிச்சு போனதுக்கு அப்புறம், ஜாப் கிடைச்சி போனதுக்கு அப்புறம் ஐ ஃபேஸ் அ லாட். ஏன்னா நான் நல்லா படிப்பேன், எப்படி படிச்சு ஒரு ப்ராப்ளமை சால்வ் பண்றது, ஸ்ட்ரக்சரல் அனாலிசிஸ் எப்படி சால்வ் பண்றது எனக்கு தெரியும். அது ஐ டிட் தட் அண்ட் ஐ காட் இன்டு திஸ் ஃபீல்ட். பட் போனதுக்கு அப்புறமேலே நான் ஃபர்ஸ்ட் கேட்ட கொஸ்டின் வந்து ஸ்ட்ரெஸ்னா என்ன, ஸ்ட்ரெயினா என்னன்னு கேட்கல யாருமே. ஃபர்ஸ்ட் வந்து ஒரு லெட்டர் டிராஃப்ட் பண்ண சொன்னாங்க. லெட்டர் டிராஃப்ட் பண்ண சொன்னதுல என்னென்ன பாயிண்ட் தேவை, என் ஹையர் ஆஃபீஸர் வந்து என்ன எக்ஸ்பெக்ட் பண்றாங்க, இந்த லெட்டர்ல என்ன எழுதணும் அப்படிங்கிறது தான் முக்கியமே தவிர அந்த இடத்துல ஸ்ட்ரெஸ்ஸோ ஸ்ட்ரெயினோ ஆக்சுவலா அப்போதைக்கு இல்லை. It is also important when it comes to technical part important. அது நம்ம படிக்கிறத வச்சு நமக்கு வந்துடும். பட் அதர் தன் தட் நிறைய ஸ்கில்ஸ் ஆர் ரெக்வயர்ட். ஒரு ஆஃபீஸ்ல போய் ஒர்க் பண்றீங்கன்னா அங்க எப்படி, அங்க என்ன எக்ஸ்பெக்ட் பண்றாங்க, அங்க உங்களுக்கு என்னென்ன ஸ்கில்ஸ் தேவை, அதெல்லாம் வந்து நீங்க இப்போதே டெவலப் பண்ணிக்கணும். ஸோ நிறைய புக்ஸ் படிங்க, நிறைய கேம்ஸ் விளையாடுங்க, நிறைய இன்ட்ரெஸ்ட் டெவலப் பண்ணிக்கோங்க. யூ கோ அவுட் அண்ட் டூ யுவர் ஓன் ப்ராஜெக்ட். ஏதாவது ஒரு ப்ராப்ளம் யோசிச்சு நீங்களா அதுக்கு ஒரு சொல்யூஷன் கண்டுபிடிங்க. நிறைய பேப்பர் படிங்க. ஸோ இதுதான் நான் சொல்லுவேன். இந்த ஸ்டேஜை விட்டுட்டு இஃப் யூ கோ அவுட், ஐ நாட் ஸ்கேரிங் யூ, பட் இந்த ஸ்டேஜை விட்டுட்டு இதை லைட்டாக எடுத்துட்டு ஜாலியாக இருந்துட்டு வெளியே போனீங்கன்னா அதுக்கப்புறம் லைஃப் ரொம்ப கஷ்டம். ஸோ வாட் ஐம் டெல்லிங் யூ இஸ் கோ அவுட், பி ஹாப்பி, ஹாப்பியாக லேர்ன் பண்ணிக்கிற ஸ்டேஜ் இது, எந்த ஸ்ட்ரெஸ்ஸும் இல்லாமல். ஸோ கோ அவுட் அண்ட் லேர்ன். இப்போ நான் பார்க்குற ப்ராஜெக்ட் வந்து எனக்கு ஃபர்ஸ்ட் புதுசு. இது இட் இஸ் அ 10 kilometer stretch of segmental construction. தமிழ்நாட்டில் இதான் ஃபர்ஸ்ட் இப்போ பண்ணுறாங்க. இப்போ நான் இது வரைக்கும் ஐ வாஸ் நாட் எக்ஸ்போஸ் டு திஸ் கைண்ட் ஆஃப் ப்ராஜெக்ட். ஒன்லி த்ரூ புக்ஸில் படிச்சிருக்கோம், பட் அதோட டிசைனோ டீட்டெயிலிங்கோ எதுவுமே தெரியாது. இப்போ தான் ஃபர்ஸ்ட். இப்போ புதுசாக ஒரு விஷயத்த போகிறப்போ எல்லாரும் என்ன எக்ஸ்பெக்ட் பண்ணுறாங்கன்னா ஹையர் ஆஃபீஸர்லாம் இந்த விஷயத்த நான் எவ்வளோ சீக்கிரம் லேர்ன் பண்ணிக்கிறேனோ அந்த அளவுக்கு எனக்கு அந்த இடத்துல மரியாதை. ஸோ உங்களுக்கு அந்த ஸ்கில் இருக்கணும். எனக்கு இதுதான் தெரியும், எனக்கு இந்த பேசிக் தான் தெரியும், புதுசாக இருக்குல்ல, இவ்வளோ புதுசாக இருக்கு, காம்படிஷன் ரொம்ப ஜாஸ்தியாக இருக்கு. ஸோ நீங்கள் எந்த ஃபீல்டை சூஸ் பண்ணுறீங்களோ, சிவிலில் நிறைய ஆப்பர்ச்சுனிட்டிஸ் இருக்கு. பட் யூ ஹேவ் டு பி ஸோ கிளியர். இப்போவே பிளான் பண்ண ஸ்டார்ட் பண்ணுங்க. நீங்கள் கவர்மெண்ட் ஃபீல்டில் போகணுமா, அதில் நிறைய ப்ளஸ் இருக்கு. நீங்கள் அப்போ கவர்மெண்ட் தான் போகணும்னு முடிவு பண்ணிட்டீங்கன்னா கோ அவுட், டாக் டு பீப்புள் ஹூ ஆர் இன் தட் செக்டர். ஸோ கெட் எக்ஸ்போஸ். அதுக்கு சார்ஸ், டீச்சர்ஸ் எல்லாம் இங்கே நல்லா ஹெல்ப்ஃபுல்லாக இருக்காங்க. நீங்கள் சார் கிட்ட கேட்டீங்கன்னா அவங்க உங்களுக்கு நிறைய ஹெல்ப் பண்ணுவோம். ஸோ கோ அண்ட் டாக் டு பீப்புள். அவங்க ஆஃபீஸில் போய் ஒரு 2 நாள் அப்சர்வ் பண்ணுங்க, அங்கே என்ன நடக்குது. அங்கே இருக்க அந்த பவரை பார்த்தீங்கன்னா யூ வில் கெட் டு நோ ஹவு நம்மளும் இந்த பொசிஷனுக்கு போனால் எவ்வளோ நல்லா இருக்கும்னு யூ வில் ஃபீல். ஸோ நான் நிறைய பேர் பார்க்குறேன் 2020 பேட்ச் 21 பேட்ச்லலாம் பாஸ் ஆனவங்க எல்லாமே முடிச்சோடனே they are getting into டிபார்ட்மெண்ட்டு. அவங்களாம் ரொம்ப ஃப்ரெஷ்ஷாக இருக்காங்க, ரொம்ப ஷார்ப்பாக இருக்காங்க. ஸோ நீங்கள் அடுத்தடுத்த ஜென்ரேஷன் வரப்போ யூ வில் ஹேவ் வெரி ஷார்ப் மைண்ட். யூஸ் தட் ப்ராப்பர்லி. எந்த அளவுக்கு வெளியே போகிறது இம்பார்ட்டண்ட்டோ, இந்த ஏஜை மிஸ் பண்ணிட்டா யூ கான்ட் கோ அவுட், யூ கான்ட் என்ஜாய்னு சொல்லலாம். பட் அதே சேம் இந்த ஏஜை மிஸ் பண்ணிட்டா யூ கான்ட் செட் யுவர் கேரியர், யூ கான்ட் பிளான். இப்போ நீங்கள் பிளான் பண்ணி அமைச்சுக்கிட்டா பின்னாடி யூ கேன் பி ஸோ ஹாப்பி, ஃப்ரீயாக இருக்கும். அந்த பசங்கள்லாம் இப்போவே ஒரு நல்ல ஜாப்க்கு வந்துட்டு நல்லா ஃப்ரீயாக இருக்காங்க. அதுக்கு அடுத்தடுத்து அவங்க லைஃப் சீக்கிரமாக கோ ஸ்மூத்லி. ஸோ அதான் நான் உங்களுக்கு சொல்கிறது. யூ ஜஸ்ட் இன்ட்ராக்ட் வித் பீப்புள், கோ அவுட். உங்களுக்கு என்ன ஹெல்ப் வேணும்னாலும் சார் கிட்ட கேளுங்க. யூ கேன் கம், நீங்கள் வாங்க, எல்லாரும் ஒரு நாள் வாங்க, ஐ ஷோ யூ திஸ் நியூ டைப் ஆஃப் கன்ஸ்ட்ரக்ஷன், ப்ளீஸ் ட்ரெஸ்ஸிங்னா என்ன எல்லாமே ஐ வில் ஹெல்ப். ஸோ லைக் திஸ் யூ மே கான்டாக்ட். ஓகே, ஸோ என்னன்னு இப்போவே டிசைட் பண்ணி செட் யுவர் பாத், செட் யுவர் கரியர். தேங்க்யூ.
Thank you for those wonderful words, ma'am.
On this special occasion, we invite our Honorable Chief Guest, Engineer D. Charumadhi ma'am, respected Dr. A. Sendilkumar sir, Dean, Academic and Autonomous, and our beloved Head of the Department, Dr. K. Murali sir, to release the proceedings of this 2 days national seminar on fundamentals and applications of textile reinforced concrete construction in India.
On this special occasion, we are gloried to invite Dr. A. Sendilkumar sir, Dean, Academic and Autonomous, to honor the chief guest with a memento.
நாடி நரம்பில் நீங்காமல் நகர்ந்திருக்கும் எங்கள் நன்றியை நாவணக்கத்துடன் சேர்க்கிறோம். We invite Dr. M. Mariappan sir, Associate Professor, to deliver the vote of thanks.
Chief guest of the function,
beloved Dean Sir, respected head of the department, and my dear faculty colleagues, my dear student friends, good afternoon to one and all present here. It's my great privilege to stand before you to deliver my vote of thanks for this 2 days national seminar on fundamentals and applications of textile reinforced concrete construction in India. First, I would like to express my sincere thanks to our management, especially our secretary sir, for permitting and approving all our requirements for conducting this 2 days seminar. And I would like to thank our main sponsor, Indian National Science Academy, New Delhi, for supporting financial support for conducting this national seminar. And I would like to thank our beloved principal, Dr. P. Govindaswamy sir, who is preside over here during the inaugural function. Thank you, sir, for your continuous support. And I would like to thank our today's chief guest, Engineer D. Charumadi ma'am, Assistant Engineer Highways Department, Coimbatore, who has accepted our invitation and being here and deliver his valedictory address. Thank you, ma'am. And I like to thank our beloved Dean, Academics and Autonomous, Dr. A. Senthil Kumar sir, who is presiding over the function and your valuable speech. Thank you, sir. And I would like to thank all our invited speakers, Sunita K. Nair ma'am from IIT Palakkad, Sachin Paul from IIT Chennai, IIT Madras, and Dr. Denmudi madam from GCT Coimbatore, and Dr. Muthura sir from CIT Coimbatore for their valuable informations and knowledge sharing to budding engineers. And I would like to thank our beloved head of the department, Dr. K. Murali sir, who is guiding and supporting us during the entire process of this 2 days seminar. Thank you, sir. And I would like to thank all our faculty members, teaching and non-teaching, who is actively participate and involved in this 2 days national seminar for successful completion. Thank you all. And I would like to thank student volunteers. Without their contribution, support and involvement, this function would not be a grand success. Thank you all students, volunteers for your supports and involvements. And I would like to thank all the participants in the today's seminar, both online and offline mode, who are present here and who are all attending through online mode. Thank you for your participation. And I would like to thank all the arrangements, PA systems, studio MCD and other refreshment, all arrangements committees for your supports and involvement. Once again, I thank one and all present here and thank you for supporting us for the successful completion of this 2 days national seminar. Thank you.
We request everyone to rise up for the national anthem. A very special thanks to everyone for your participation and cooperation in the successful conduct of this national seminar on fundamentals and applications of textile reinforced concrete construction, sponsored by Indian National Science Academy. Thank you, everyone. We request everyone to assemble at the same venue at 1:30 p.m. Thank you.